Hello everyone, welcome to my channel. Today we are going to discuss about the integral of these two forms, that is a sin x plus b cos x upon c sin x plus d cos x, or we have the another form, that is a e raised to x plus b upon c e raised to x plus d. We are going to study if you have the question of these two form, how to deal with it. So we have the 4 steps here. For in the first step, you have to express your numerator as a times the denominator plus b times the derivative of denominator. Okay, then we have to find the values of a and as well as b. After finding the value of a and b, the third step is I is equal to a times integration of 1 dx. How we get the 1? I will solve it in the example. Plus b integration of derivative of denominator upon denominator, it will come. So in the fourth step, we get I is equal to the integration of 1 is x, so that becomes ax dx plus not dx, so we'll rub this out, yeah, plus b times log of denominator. Why? Because we have a derivative of denominator in the numerator, so that is why we can write this from. Now let's just take an example and have a look how do we solve like this. Okay, now before going to that, just remember that in this form you have to remember that in the denominator we shall have sine as well as the cos, but it is not necessary that we shall always have sine and cos in the numerator. Sometimes it may happen that you may come across only sine and or cos in the numerator. Okay, now let's just move on to the next one. So we have this problem here, this one, I is equal to integration sin x plus 2 cos x the whole upon 3 sin x plus 4 cos x. I have taken a general example here including all sin and cos in the numerator. Okay, so we have this. Now first step is to take a numerator. So we have here numerator, I will write this numerator 1 sin x plus 2 cos x. We have to express this numerator as a times denominator, that is a multiplied by 3 sin x plus 4 cos x plus b derivative of denominator again. So I'll just write this down and we have to take that derivative in the next step. So I can just copy this down here, 3a sin x multiplied by 4a cos x. I have taken the a inside plus b. Now derivative of 3 sin x, 3 as it is, derivative of sin x is cos x, plus 4 will be as it is, derivative of cos x is minus sin x. Okay, multiply with b outside here. So we'll write 3a sin x plus 4a cos x, multiply b inside, that gives you 3b cos x minus 4b sin x. Okay, now just collect the terms of sin x. So we have this sin x over here and sin x over here. So take the coefficients. We have 3a here and we have minus 4b here. So that will give you this. And collect the terms of cos x. The coefficients of cos x is what? 4a and this is plus 3b. Okay, and on the left side you have 1 sin x plus 2 cos x. Okay, so we have the sin x as well as the cos x on the left as well as on the right side. Okay, so what you can do, you can equate your coefficients of sin x as well as the cos x. So the equations of or the coefficients of sin x and cos x will be 3a minus 4b will be equal to 1. Okay, and the other one is 4a plus 3b is equal to plus 2. So we have got these two equations. You can solve these two equations simultaneously and find the values of a and b. Okay, on solving it, you get the value of a as 11 by 25 and the value of b will be 2 upon 25. You can solve this simultaneously and find the values of a and b. So we have done the step 1, we have done the step 2, now the step 3. So the step 3 was writing the numerator again, 1 sin x plus 2 cos x, okay, is equal to a times, so this will be a times the denominator, which is nothing but 3 sin x plus 4 cos x, okay, plus b it was 2 upon 25, and the derivative of denominator we have already found it, 3 cos x minus 4 sin x. Yeah, so we have expressed our numerator in these two terms. Now I'll use the integration I. So in the numerator we will have this big term over here. I'll just again write this down, 3 sin x plus 4 cos x plus 2 upon 25, 3 cos x minus 4 sin x, and in the denominator it will be 3 sin x plus 4 cos x, okay. So in the numerator we have these two terms, we have this denominator, common denominator, so we will give this denominator to the first term as well as on the second term. So after giving it to the first term, we have 3 sin x plus 4 cos x upon 3 sin x plus 4 cos x, okay. I have separated it, and this will be 3 cos x minus 4 sin x upon 3 sin x plus 4 cos x, okay. Now these two terms are same, so what we can do, we can just cancel it, so this will get cancelled, okay. So then it will be, we can take 11.25 outside, that we left with 1 dx. I hope you understood how we get the value as 1, okay, and 2 upon 25 is the integration of this, which is 3 cos x minus 4 sin x upon 3 sin x plus 4 cos x. Now if you just note it over here, what we have in the numerator is nothing but the derivative of the denominator, okay. So we are using the property, integral property. I'll just write it over here, that is the integration of f dash of x upon f of x. So the original function is in the denominator and you have the derivative of denominator in the numerator, so that gives you log of mod of f of x plus c, okay. So this is the property of the integration, so here we are going to use this one. So the final answer would be 11 upon 25, and the integration of 1 would be x plus 2 upon 25, and here we have the original function in the denominator, so this will be log of mod 3 sin x plus 4 cos x plus c. So this is how we have solved the first kind of the problem. Now we will have the another type of the problem, which is in the exponential form. So here I will be equal to integration 20 plus 12 e raised to x upon 3 e raised to x plus 4. Hope you understood the last problem here. So now we will do the same steps again. First we will take the numerator. Numerator is 20 plus 12 e raised to x is equal to a times the denominator plus b times derivative of denominator. This is the denominator again. We can take a inside, that gives you 3a e raised to x plus 4a, again b, and the derivative of 3 e raised to x is 3 e raised to x plus derivative of 4 will be 0. Okay, so now take the coefficients of e raised to x. So this will give you 3a here and 3b there, and the this will be 4a, and this is 20 plus 12 e raised to x. So here we have the coefficients of e raised to x as 12, and here we have 3a plus 3b. Okay, so we can equate the coefficients and write here, and this is the constant 20 and this is 4a. So 4a will be equals to 20, so a we have got 20 by 4, which is equal to 5. And on the other hand, this is 3a plus 3b is equal to what? 12. Taking 3 common, a plus b is equal to 12, that gives you, dividing by 3 on both sides, that gives you 4. Substituting the value of a, that is 5 plus b equals to 4, b is equal to 4 minus 1, which is minus 4 minus 5, which is minus 1. So here we have got the value of b as well as the value of a. Okay, now there was no need over here of solving this simultaneously, we can just directly get the answer. So the value of a is 5, value of b is minus 1. Now we'll express our numerator was 12 e raised to x plus is equal to, that will give you 5 times 3 e raised to x plus 4, and this is minus 3, the value of b, e raised to x. Okay, you can just check it over here, this one. So yeah, that's it. Now what we can do here is, we have expressed our numerator in this form, that is the value of a substituted as 5 and the value of b is coming out to be minus 1, that gives you minus 3. So I think we have written this minus 3. Okay, now what we can do, we can just integrate this quickly. So we'll write this in the numerator, just copy this down, the whole upon the denominator what we have, 3 e raised to x plus 4 dx. Okay, now we'll give this denominator to both of this term in the, so that gives you 3 e raised to x plus 4 upon 3 e raised to x plus 4 dx minus 3, and this is 3 e raised to x upon 3 e raised to x plus 4. Okay, now one correction I'll do, we'll take this 3 inside here. Now this and this will get cancelled, so we left with 5, we'll take 5 outside, 1 dx minus integration of 3 e raised to x upon 3 e raised to x plus 4 dx. Now the integration of 1 is x minus, again if you check this out, we have the derivative. See, this is our denominator and the derivative of denominator is present in the numerator. Okay, so again we will use this same formula, f of x we have in the denominator and the derivative is in the numerator. So the value will be log of mod of f of x plus c. So here also we will use the same property, that gives you log of denominator, which is 3 e raised to x plus 4 plus c. So this is how we have solved this two type of the integral form along with the steps. Okay, so hope you like this video. Please also work on this, it is a very important question and it may come for your board exam. Okay, thank you for watching this video, have a good day.